Hey guys. Hmm. Let me see. Yes, we got 12 people on right now. I'm finishing my I don't know what this is, lunch. I'm going to take just a second, finish my cheese stick, and let a couple more people jump on. Okay. Lunch. Thank you, Brendan. That is lunch, I think. I have another one, but it's 11:32, and I think I need to wait, and I don't want to be like, you know, eating a cheese stick into the mic, you know. Okay, let's see. All right, so signal stuff is good. We're doing pretty good. All right, yeah, how's everybody doing? What's happening? How's everybody coping? Okay, hey, listen, I'll wait for those responses to how's everybody coping, but okay. Boom, boom. Okay, so here's a burning question. One of the things that happens as we get into this is there's a latency. Um, Even though my OBS is showing a latency of like it's saying 5 seconds, but I think that's sort of an internal 5 seconds. Then there's a kind of a natural delay as it goes, pipes into YouTube Live, pipes over to YouTube, and then pipes back out to the world. And there's just this natural, inevitable delay. So I've been experimenting with something. And the thing I've been experimenting with, actually, hold on, is how to get this thing refined. The way we've been doing it, I think, is actually pretty darn good. But there's a latency. So whenever I've got like questions, it's sort of a struggle because we can't do the interactive thing as readily. Got two ways of doing this thing. One way is, and we can try this, see what you think about it, is we jump on Discord. We just jump on the testing lobby on Discord. And there's a voice channel. And we just go to the general voice channel. And in fact, I'm just going to do it right now, which I did. I opened up the general voice channel on the testing lobby on Discord. And then I know someone's going to ask. So there's the link if you're not on Discord yet. If you're not on Discord, get your butt on Discord. Anyway, you can then just jump over on Discord. There's a voice channels general, and you just click on the where it says general. And I wonder, yeah, let me see if I can kind of show you what that looks like approximately. Yeah, there we go. Yeah, so there I am right there. And you can just, when you get in here, this is the Mac Discord client, so yours is going to be a little bit different probably. But just go over here and join the general. And then what you'll get is essentially my voice with a lot less latency, and then you don't have like the 20-second round trip and everything. And it'll just be, it's a lot more interactive that way. So we'll just see if anybody wants to jump in. And then the only key there is when you do that, what you want to do is kill the sound on your YouTube video, okay? And if you're on like a phone, you may have to decide whether you're going to jump over on Discord or be on YouTube, but you can't really do both, probably. So anyway, if anybody wants to jump over to Discord, there we go. Who do we got? Yeah, that's right. So anyway, for those of you on Discord, and then make sure you mute your mic, unless you've got like a headset or something that doesn't, there's not a lot of background noise. You want to probably mute your mic. That's the little mute, and you control that down here. You can see where mine is. There's the little mic that I can I go like that. And then those of you on Discord can't hear me, and then unmute it. Okay, so you do the same thing. I think that's not going to be too bad as a way to get a little bit more interactivity. And then, of course, if you want to just stay on YouTube and just work from the chat, from the text chat, totally great, no problem at all. The other advantage to doing the Discord thing is that we've got kind of a nice live spot for any issues or things that we talk about. We just drop them right in to Discord, kind of in real time. So that's kind of like, hang on a second. All right, just a second. The other thing I want you to be thinking about is anybody having any experiences with Microsoft Teams? Okay. Are you guys doing Microsoft Teams in any of your other classes? And if so, I would be really curious what your experience has been, because who's Polaris? Who is that? Yeah, so I got Zach. Who's Polaris? Zach. I asked you that yesterday, I think, Zach. Sorry, man. I'll get it figured out. Yeah, so we got a pair of Zachs, a pair of one-eyed Zachs. I'm just curious what your experience is on doing Microsoft Teams. James says it works pretty well. Because we can do that, and the one advantage to doing Microsoft Teams, of course, yeah, because, okay, here's the thing. I can still set up a live stream to YouTube. I can still take the experience, stream it using OBS. I can still stream the thing to YouTube. What's your experience? You guys, do you think we should go that route for a little bit more interactivity? What say you, friends? Vlad thinks it's great. Anybody else besides Vlad? Brendan says it's good. You can also, by the way, you can just unmute and voice and drop in on the voice channel if you like. No mic on your desktop. Thanks, Brendan. Right, so I guess question, who is that? Who's Wild West? That James? Easier to make comments and view what you're doing. Yeah, I think so I think what I'm going to do, I've still got to I just want to make sure it's kind of like configured okay, and I've got it kind of set up. Let's roll with that next week and try it. And the key would be, you have to do, my original idea was so Vlad said Teams is better than Hangout. My original idea was to try to just avoid a situation where in the middle of all the crunch and the switchover that you guys found yourselves having to install a bunch of stuff, And, because with YouTube Live, you just, boom, you go. But then we're like, well, Discord for chat anyway, for the testing lobby. And it turns out there is a university license for Microsoft Teams. And with the brilliant genius of OBS, I can set up a stream from just anything going on my laptop. I can stream it back out. So I can still give the YouTube experience, and there can still be live chat on YouTube, where if that's their best way to get to it, you just have the latency is all. And if you're okay with that, I'm okay with that. Kaltura. Okay. All right, thanks for the feedback. I think, let's see. The Canvas Live. I've had up and down reviews on the Canvas, whatever they call it, living room, live room, Canvas something. I've had mixed reports. Yeah, I've heard bad things. So, all right, pals. Everybody doing okay? You guys holding tight? Yeah, good feedback, Zach. Okay. I've heard mixed bags on Kaltura and the Canvas thing. What are we doing? Should we learn some stuff? Anybody want to learn something? I think we're still in chapter 7. Where are we at? Everything's slow. I got so much crap running right now. Okay. Oh, you know what? I was going to fix these stupid slides. I was going to fix the slides. Grading. Did we talk about? Yes. Did we? We didn't talk about the grading, did we? Let me talk about it. Yes. Thank you. Thank you for the reminder. That was something that I wanted to make sure and talk about. Okay. Okay. So let me pull up real quick. Boom. Okay, hold on really quick. I'm just pulling up. I didn't have it up. I guess I lost track of which ones. Okay. Okay, let me drag these over. Ba-boom. Okay, that one is the college little flyer, whatever, news flash. and then this one is the university. Okay, so let me start with, first of all, let's blow those up. Let's start by asking, it's probably too big. We could ask Wilson. Did you see that? Ask Wilson. Wilson. Having flashback to Castaway, Tom Hanks. I don't know why I should ask volleyball. Okay. Where am I at? Where am I at? Okay. Sorry, I gotta I need a couple of big monitors is what I need. And I've only got the one extra monitor here in the home office. So, okay, and for everybody else, right now we're at 20 concurrent viewers. And anybody that wants to jump over, we've got 3, 6, 7 on Discord. And presumably the rest of you are on YouTube Live. Well, there's 20 on YouTube Live. Yeah. Anyway, just as a reminder, if you want to jump over on Discord, you've got more live voice. There's less latency. And you've got the ability to unmute and, contribute, just talk directly into the channel. So, okay, let's talk about this thing. So here is what I understand so far about what our options are. What are your grading options? It starts with a bunch of words, and everything's unprecedented. So, we're going to give you a couple options that aren't normally available, and we're going to encourage you to keep going. I agree. Keep going. So the first big recommendation is press forward, earn the letter grade. Okay, just to kind of keep in mind that if you take, so Zach, yes, there is a 30-second difference between I'm gonna be talking, you're gonna hear it almost immediately in Discord, and then you're gonna hear it on YouTube. So I would mute the YouTube audio, where you've got the YouTube video, where you can see the video, but I'd mute the audio if you're listening on the Discord channel. Okay. So anybody out on the YouTube thing that, if you don't have Discord already, get it. Okay. Okay. So strong recommendation from the university is just keep the default. And if you don't do anything, then the default will be a letter grade. Okay. If you don't do anything, that's what it'll get. I think there's some form that you can do. You want to talk to your academic advisor, and I think there's something that you have to fill out to get the credit, no credit option, or the W. Okay, these are the three right here: letter grade, credit, no credit, withdrawal. Okay, and the W date on that is a lot later than normal. I believe that all of this has to be done by April 24th, I think. I believe that is the date that that I was told, or that I read. So, let's see. Okay, yeah. So, hang on a second. Yeah. Let me just. I did this once before, but for those of you. For those of you that are just kind of checking in, your own thing right there is your mute button for your own microphone. And then you're going to go up here to the testing lobby, and that's going to be, right there, voice channels, general. You click on that and you're dropped into the channel. Okay. Let me move that off. Okay. Okay, So just to reiterate, this is strongly recommended. The problem is right here. This taking the credit, no credit can have negative consequences, so just be aware of that. Also, if you are an international student, options 2 and 3 are not available to you. Okay? The credit, no credit, and withdrawals are not available to you if you're an international student, here on a student visa. Don't know all the reasons why that is, but that's the case as I understand it. And here's the deal. One of the questions is like, well, what kind of a grade does that mean? What kind of a grade does that turn into? And the answer, or not what does it turn into, but what does it sort of suggest? And the answer is that you have to accomplish a passing grade, C minus or higher, in order to get the credit. Okay, so it's still, what is that, 70% or something like that. So you still have to succeed in order to get it. You have to decide whether this, there's a number of reasons why you might want to consider it. If if there's particular struggles that you're having and you don't want to have that C minus on your grade, whatever, when you take that credit, no credit, it doesn't affect your GPA. And so that means it kind of both positive and negatively, right? If you were looking for the bump on your GPA by doing well, it's not going to cover that. If you're looking for, you've taken this class before and you're taking it a second time and you want that grade to cover, I think you've got to have a letter grade to pull that off. These are the, potential consequences. So I want to just point you to these, and you've got to be responsible to give this a full read, okay? But, if you got Pell Grants, loan, scholarship, then you can be impacted by the credit, no credit. So go there, hit that link. Oh, and by the way, let me just throw this out there. I'm going to throw the link so you can just kind of get to it. And I'll throw it there as well. So I just threw it out to Discord and to YouTube. And then I'll copy the other one as well. But so be aware if you've got any of that kind of aid. I'll come back to program requirements. Graduation GPA, just be aware of that. I don't know all the details on that, but just remember it doesn't hurt your GPA, but it doesn't help you either if you needed that. Now, this prerequisites and program requirements. So, hang on. So the program requirements and then prereqs right here. I want to kind of talk about those together. That actually relates to this part here from the college. Okay, right there. So this, if you change your status, then, it kind of says you're only going to get credit if your overall score would have earned you a grade of C minus or higher. And then right here, a credit grade will not be accepted in the following programs. And then for computer science, it's matriculation courses. Okay, so that's like 1400, 1410, 2300. I don't even remember exactly which ones are the CS matriculation courses. I have it written down somewhere, but not right here in front of me. Some of you already know that anyway, but so, and 2810 is not a matriculation course, so it is available as an option in this class, okay? And then definitely talk to your advisor. Definitely talk to the advisors who are going to be able to give you a little more, information. And then let me drop that link over to everybody. So Brendan, I'm just curious what you said. I hope they'd relaxed rules about CRNC grades during this semester. So I think this does reflect relaxing of the standards on that. To what extent, I don't know, but it is a relaxing. For example, starting with the deadline back to April 24th for withdrawals and credit, no credit. And even the ability to just take these other classes, like even the ability to take 2810 as a credit, non-credit, is a change. That's a relaxing of the things. So anyway, look at that. Okay. Oh, the other one to kind of keep in mind. Oh, I see what you're saying, Brendan, about courses not having prereqs, things like that. Yeah. Still a little evolution. These things might change just a little bit. I want to just say a couple things that may be interesting. So as we said already, international students, I'm sorry, I didn't make that rule. And that's just a thing. So you just don't have the option. But course transferability, if you're going to stay at UVU, less of an issue. If you wind up transferring, there's more of an issue. I'll give you one example, something that happened to me many, many moons ago. 35 years ago. So I was at the University of Iowa. And while I was at the University of Iowa, I had it was a PE class. It was weightlifting, in fact. And I'm still packing it after all these years. So in this weightlifting class, I got an A, as you can tell. And but at the University of Iowa, for some strange reason that I really don't understand, in order to have any PE class that was going to count as general ed for PE credit had to be pass-fail. Why? Who can say? But so I earned an A, and the grade I received was P for pass. Didn't really affect me, didn't help me or hurt me. Well, I mean, I got an A, so it would have helped me. Just every A helps just a tiny bit, unless you're rocking a 4-point. Anyway, then I transferred to BYU, and then it just so happened that the rules at the two schools were exactly opposite. This is opposite. And so at BYU, the rule was that in order to count PE credit as general ed, it had to be taken with a letter grade. So I had the PE credit I needed because I'd taken it at Iowa. But now I was faced with this dilemma because in order to count the credit from Iowa for my PE at BYU as a transfer student, I had to convert the pass-fail grade into a letter grade. And it turns out that when you come transferring in someplace with a pass grade, and then they have to convert it, at least what they did at BYU back then was they converted my pass grade from Iowa, and it turned into a C. So I literally got a C on my transcript for transfer credit, which affected my GPA, which eventually cost me like graduating cum laude. It was like thinnest of margins. But I had actually, I benched plenty. Okay, I benched plenty, just so you know. I was skinnier then, so I didn't have to bench as much. But anyway, I could bench 150% of my weight. That's all right, I think. That's not too bad. And military press my weight, so that was all right. Couldn't do that today, I guarantee you. I'm fatter and weaker. Anyway, so you know what I mean. I take a class, I earn an A, it turns into a P, I transfer it, and it turns into a C. That's just rip. So just be aware that just goofy stuff like that happens if you're going to do any transfer stuff, okay? And sometimes they're not going to accept them at all. So just be aware that puts you a little bit behind the 8 ball. And then grad school, I just want to say real quick about grad school, because some of you are thinking about grad school, and I think it's fantastic. I think if your heart's on grad school, you should definitely, I think you should definitely go for it, man. If you're thinking grad school, I'm a big fan. So the credit, no credit again in grad admissions, they might not take it. Now, it's also possible that they'll look back and say, oh, spring 2020, yeah, there was a lot of that going on and make an exception. But you do put yourself into a position of needing to ask for the exception. And if you can just get the letter grade, it's going to be straighter. What else? One other thing, where was it? I think it says it somewhere, but about the W's, it's probably right here. Yeah, right here. Withdrawals are common on college transcripts. Yes, I just want to say the W by itself doesn't really make much difference. I've been on graduate admissions committees and, at BYU and at Oregon State. I think, yeah, I think both. And, everybody has a W along the line. It basically just means I dropped this class after the drop date. Why would anybody do that? Oh, every reason. So it's like nobody's stunned by that, okay? So don't worry on that front, okay? Even a whole semester of W's just says, wow, something happened that semester. Student got ill, family crisis, stuff happens. So everybody knows that. So that's not a big deal. Okay. Anyway, so hit those things. I've given you the pointers to those. Do you guys have any questions at all? Chat or voice? So Brendan, do you have an audio? Do you have a mic where you are? Because anybody who's on the voice channel can just unmute and say, yo. Okay, excellent. Yeah, keep working. Keep working on that, guys. You're gonna get the yo down here in a little bit. Just follow Dr. K, but you gotta yo. That's the Okay, right, Brendan. All right. Okay, man. Let's do the thing. We were talking about stuff, right? Weren't we learning some stuff? Seem to recall us trying to learn something. Let me get rid of those and fire up. Oh, so I was going to say, I was going to go tweak the slides, and like an idiot, I didn't. I was going to. I don't know. It's hard. You guys finding that? It's a little hard to just do stuff. So, I think you know what I'm talking about. It's just been really tough. All the rhythm is just kind of trashed, I was watching an interview yesterday, day before, with Kevin Love. For those of you who don't know, there's a game among our people called basketball, and Kevin Love is one of the really great players of this game of basketball. He's on the Cavs, Cleveland Cavaliers. Anyway, and he was just talking about, how as a basketball player, it's supposed to be the season, should be in the playoffs right now. And anyway, just there's a rhythm, you're up your certain time schedule. I got my workout, I got my things, and then all that kind of gets disrupted. Maybe you're hitting the gym, or maybe you've, whatever. And again, for the deep gamers, you're probably just like, what? Nothing's changed. You're doing it right. You're doing it right, gamers. Just keep going. You're doing fantastic. Just keep social distancing like you have since you were 14. It's just great. I have some kids in that category. Okay. We did. Oh, we did. We did some LC3. I remember. We did some LC3. On the simulator, which was cool. I thought that was good. And we can also, kind of play with this program here as well, this assembly language program. And it's what we're trying to get to here is sort of bridging the gap between these bits, these are bits right here, this binary world of bits. And then all of a sudden you're like, wait. I can just say load whatever's in the memory location I called 6, and I can put it in R1. And the answer is yes, you can. And that's called assembly language. And even as you are now excited today about this transition to a higher level view of this world of programming, even so, the people back in 50s, 60s. I don't know when assemblers were built, 50s probably. Were pretty jacked at being able to write code like this instead of just writing codes as zeros and ones. Seriously a thing. Okay, so we talked, as I recall, we talked about the pseudo ops, the assembler directives, and we hit all 5 of them, as I recall. And we were going to hit the trap codes, but I want to just back up again and just suggest, as I did last time, to just remember that all these instructions, LD and, add, BRP, halt. Well, halt is a trap instruction. But this BRP, add, and load. You've got to become really comfortable with hitting the documentation. It's the appendices in the book, if you have the book. It is there's a PDF of just that part that I put on Canvas. So you can look that up, and it's going to give you the syntax. It's going to give you the opcodes, the full binary representation of the instruction. It's going to give you all of that. So don't be guessing, okay? Please, please. I beg you, don't guess when you're writing code like this, okay? Do not guess. If you're guessing, I don't know. If you're guessing, you're messing. If you're guessing, you're toast, okay? That's the bottom line. Okay, so here's a question. We can do a couple of things right now. We can do a little more of this, like dropping this program, into the LC3 simulator and kind of walk through that a little bit. A little partial to that. We can talk about the trap instructions, of which halt is one, which was coming up right here. Okay. Now, we haven't talked about how to really, what those trap instructions are. There's some mechanisms behind it that we really haven't talked about. But, and then we go into this process of how you do assembly. You guys, if you have preferences, it's a good time to express those now. And then I'm just trying to see how many slides we have here. 54. We're doomed. No, we're not fully doomed. No. A bunch of it is like animation slides. No, it's not going to be too bad. Yeah, it's all about the assembly process. That's right. That's what takes all those slides. Okay. Just wanted to remind myself. So what say ye, gentle friends? Yeah, so I don't know who Chasik is, but what have I got here? William. Okay, yeah, William. Yeah, you are doomed. Yeah, that is the problem with the Discord chat. So let me do. So anyway, William was just saying, that it's a problem with where you're seeing the screen 30 seconds after I'm talking. So this is the trade-off. This is why we probably need to try Microsoft Teams. I think the overall latency might just be better, and then just YouTube Live will just be almost like an out-of-band artifact as opposed to the primary delivery mechanism. That's the key. And the problem is you either wait on all the latency. If you, well, and you're free, William, and everybody, you're free to listen on the YouTube, sync up to the YouTube broadcast, and interact via chat. For now, you can kind of pick your poison, in which case everything's going to be latency and your responses will be delayed. Whereas on Discord, you're going to hear my voice immediately and the video is going to be delayed. I don't know, guys. I'm not quite sure the best solution. Anyway, but it's kind of individualized right now. Do whatever do whatever works for you. That's kind of the bottom line. But it's an excellent point, and that's the dilemma. Let's do this. Let me talk about trap codes. And I think the other animation slides are going to do a decent job of walking us through some of that stuff. And then when we have some time, we can go back to, hang on, we can go back to the simulator. which I think it's good to spend some time there. So here's the bottom line, okay? We have not talked about how trap codes work, okay? So it's okay. It's okay for now. This is just a point of reference. But what you can say in the code are these 5, they're kind of like instructions, okay? But they're not. The assembler sees halt and it substitutes for it trap 25 or trap hex 25. Okay? All you need to know for now is that in the code, you can say halt. So for example, like right there, you can just say halt and good. You're good to go, okay? And you can also say, remember we did this where we did a .string z in the simulator. So I had this ASCII null terminated string, right? And then you had to put the address of that string in R0, I think, if I remember correctly. And then you can just say put S and give it, well, it's just going to assume R0. And then, oh, there it is. It's right. Yeah, I don't have to remember. It's right there in the documentation. Okay, yeah, it's right there. Starting at the memory address stored in R0. And then I can just go put S, and then the string gets printed to the console, right? Now, I don't have to say trap 22, trap 20, trap 21. And the mechanism of how that works, we're going to get to it, okay? And so you don't have to worry about it for now. But just know that you can say these things. That halt, you have to call halt to stop the program, to make the program stop running. What else? In and out. Let me see. When you do in, it actually prints like a default prompt out to the console. And then, you press like one character and then it stores the character. That's it. And very similar to get C, where you'll notice read one character from the keyboard, store the character. So what get C does not do, by the way, when it says read and echo, okay, you have to understand that we're used to a world in which, we jump on chat or on whatever we're typing, right? And as we type, characters appear. But you have to understand that these are 2 different operations. When I'm typing, I'm pressing the keystroke, which causes scan codes to fly, across the wire if it's a wired keyboard or wirelessly via Bluetooth or whatever. So when you press keystrokes, it causes scan codes to be sent to the computer. There's nothing inherent that makes that pop out to the screen. The system has to take the keys that you pressed and then know what the character is supposed to be, and then we call that echoing. Okay, or in other words, I press a key and then it's going to echo that back to the screen. I press a key, the system's now going to print that to whatever my environment is. The chat window, my Word doc, the console in the case of like this LC3 simulator. Okay? So when you do in and it prints a prompt, that's a helpful happiness. Reads a character from the keyboard and then echoes that character to the monitor and then stores that character in the bottom half of R0. In other words, the rightmost 8 bits 0 through 7. Get C just reads the character and stores it. Okay? So the problem with in is you don't always want to print a prompt to the console. That's bottom line. Anyway, but you will do things where when you write your program and the user has to type things, and we'll walk through that on the LC3 as well. It'll hopefully make some sense. What else? We did halt. We did in and get C. Out basically takes the character that is stored in R0 and writes it to the console, prints it to the console. So essentially what in does is it prints out the prompt, calls get C, and then calls out. Basically, that's what in is doing. And put S we demoed for everybody. Just, you give me a string, null terminate it, means there's a literal value 0. All the bits are 0 in that spot. That's the end of the string. Okay? If you look in the ASCII table, character 0 actually says null. You know, it's like not a real thing kind of thing. Not a real character. Okay. You guys have any questions at all with that? With the trap codes or the pseudo ops, this kind of like formatting, how we do this thing. Oh dear. Or the way this program works. Any stuff there before we jump to the next part? I know there's a little bit of latency for those that are on the slides or on the YouTube broadcast. What do you got? Anybody? Yeah, so Zach, if it wasn't null terminated, it would keep reading memory till it hits 0, right? Yes, absolutely. It literally just, when you do the put S for the string, it just goes, you know, it goes to the memory location that you give it in R0, right? And it goes to that location, and it pulls out the character, and it basically calls, out, okay? Just calls out. Then it increments the memory address that it's looking at, which is the next spot in the string, checks to see if it is 0. In fact, we can look at the put-s code that's built into the LC3 and you'll see it. Checks to see if it's 0. If it's not, it grabs that, prints it out, does it again, just keeps going. And so it doesn't really care that you only had like 10 characters for your string and you overwrote the last one and you blew past it. It doesn't care. Do you guys want to, should we do that? Do you guys want to look in the, you can tell I'm pretty flex. Do you guys want to look in the put-s code or even the in code? Any of these. We can look at any of these. But we can look at the put-s code, which will actually, you can see that thing marching, you know, forward. You guys have done looping, right? Branching, conditional. You've done all that stuff. What's your level of interest? Do you guys want to go pull up the LC3 simulator and hit that? Or do you want to like do this assembly process where we kind of like walk through some of those, behaviors? Zach says LC3. Brendan says whatever. Everybody else is silent. This is about to be a majority. Well, okay. So James, I don't know what hit it means. It's an either or. You can't say hit it. You can say hit it. I just won't know what it means. But okay, I'm game. Let me see if I can. Yeah, okay. I did ask if we wanted to hit it. You're right. Okay. Okay. Let me. I may have to. I'm not sure if how that shows up. I gotta check my OBS. Yeah, you can see that now, right? Okay. That. I'm gonna make that a little smaller, okay? If you're okay with that. I mean, just the text. If you can, you gotta let me know if you can still see it. Hopefully that's still all right. The problem is, we lose. I can stretch it up here a little bit, buy a little more real estate. That's not too bad. Yeah, that's pretty good. Okay, friends, so here's the deal. We're going to make a program, okay? And our program is going to be, I don't know, super dumb. We'll go .orig, put it in 3000. That's where we're going to start it. And just going to start my indenting now. And all we're going to do, what did we do last time? Load effective address, R0, comma, and I think last time we had a string, we called it S. And then, oh yeah, put S. halt. Oh. And we do the sudo op, string Z, and we're going to call it Dr. K for the win. And we might as well mix it up a little bit. Where's that? Let me see. Does the .org want to typically be? I don't know. I don't know what the proper formatting is there. Anyway, and then there's the .end. Okay, everybody cool with that? So again, we got the .org, which is where it starts. I'm going to assemble it, make sure I didn't do anything stupid. I did something stupid. The offset S is not a valid numeric literal. Oh, I didn't give it a name. Label, dumb. Dr. K for the loss. Yeah, you see what I did? You see what I did? I forgot to throw S over there as a label. So when I got up here, it's like S. I got no S. That's, you didn't, so I don't know what that is. It's not a literal value. I'm going to freak out. So I give it the label. Now we're happy. Okay, that's it. There's my program. There's my whole program right there. Now, here's what we can do. And the program counter is set to 3000 or hex 3000. Just hard to say 000. So here's what we're going to do. Notice that the string S, right, there's characters. I guarantee you that's capital D, little r, that's a period, that's a space. I do recognize that one. Capital K, space, capital F, T, W, exclamation, null. Okay, that's my null right there. So what happens is we got to get, so R0 you notice is 0. And we know where S is. It's at location 3003. And so what we're going to do, there's these two, there's step and next. By the way, you got to start playing with this, okay? If you haven't done it already, you got to start now. Go just search for LC3 Simulator. And here is, it's just it's an open source one on GitHub. I'm going to just post it as well for anybody that wants to either just get to it. Josh, put SP. No, I think, let me just check something real quick. Josh asked the question about, no, it's put S. I don't know if you can see that, Josh. Is that coming out all right? Yeah. So Josh asked the question on Discord, what is put SP? And I don't think there's a put SP, but there's put S. And I may have said it wrong. Okay. So let's go back to, hang on. Okay. Okay. So back to this guy. We've got, there's step and next. Okay, run just basically goes, by the way, let's just do run. Run basically just says take off, go. Okay? And it goes Dr. K for the win, halting the processor. That's just like go. Run your program. Then I unhalt. I reset all the registers. I can clear the output. And I'm kind of like ready to go again. Okay? And there again, that blue kind of shows me the current instruction, but there's the PC also shows it. Put SP, hang on. Okay. Okay, sorry, it's okay, Josh. I get that you're behind on the thing there. Maybe there is a put SP. Yeah, there is. Oh yeah, I'm a dork. Okay. Yeah, I forgot. Okay, so there is the documentation. Hang on a second. Yeah, let's hit. So no, fair question, Josh. I just like spaced on that one. So put SP, I got to go over here because better visibility. Put S writes a string of ASCII characters to the console display. You know, they're from a consecutive memory location, right? And you just keep going until you get a 0. What put SP does is writes a string of ASCII characters to the console, right? Consecutive memory locations. Oh, two characters per memory location. Okay, I think the P, what does the P stand for? Like packed, maybe? I don't remember completely. And basically the ASCII code in the low bits written first, and then the high bit. So you can basically sort of like save memory. So you don't have to use, 2 bytes for every character. And character string consisting of an odd number of characters. Right, in the very, very last one, you would have just 0 pads with zeros. Yep, and then you've still got to get to all zeros in a memory location. That's the answer. I don't think I've actually used it, which is probably why it didn't stick in my head. You notice it didn't make it into my slides. Yeah, I mean, I obviously seen it before and probably talked about it in class, and then it's just like I haven't used it, so it doesn't stick. So yeah, great question, Josh. I appreciate that. Okay, yeah. So let me go over to, boom, back to there. Okay. So what we're going to do this time is a little bit different. Checking the clock here. We're doing okay on time. Now, stepping next, okay? So, see if I can read that better over here. So, step basically says execute the next instruction, and if it's a call to a subroutine, go into the subroutine, okay? And what next does is it says execute the next instruction or subroutine, with that fully execute it, which means, we'll walk through this and I'll show you what it means. It means basically don't drop in. It's just like the following, okay? So if I say next, we're ready on this LEA instruction, right? I say next, and that instruction executes. Notice that load effective address for S, C and R0, sorry, I covered it. C and R0, 3003, that's the address of this string, right? The first character of a string. All right, all cool. Now I say next, and it's going to do put S. So in other words, like there's a subroutine, and I'm stepping, but it's like when you get to a subroutine, just call it and then step over it. Just drop me after it. I don't want to drop into it, just drop me after it. Okay? It allows me to just kind of walk through things at a higher level. And then I can go halt. Boom, we're done. Okay? Now, in contrast, I'm going to just do what we did before. I just unhalted and then reset the registers, cleared the output. Now here we go. But what we're going to do this time is we're going to do step. Step's going to say, oh, you got a subroutine call. I'm going in there. I'm dropping in, and I'm going to now step you through the code in the subroutine. Okay? So, and if it's just a regular instruction, it has no difference. It's no difference, right? Step, next, same thing. So I load the effective address, right? And there's our 0 again, right there, with 3003. Again, that's the address of S. Now, this is the key. When I say step, we're going to be inside the code. Get ready. What happens next will shock you. That's my version of clickbait. You can do what you want with that, right? Okay, I step. Boom. Now I'm inside this other routine. Now, again, the mechanism for how it did that, we haven't really talked about, and it's okay. We're going to get to it kind of in due time. Just understand that when you say, when you call that trap instruction, then it has a way of like getting you to the subroutine. And this is just a built-in function that's in memory. Okay? Now, I'm just curious. Okay, there's the ret, there's the return. Okay? So what you notice is that, oh, there's the whole thing. Ooh, that's great. We can see the whole thing in one shot. What you see is that this entire put S routine, this trap routine, occupies, what is that? 2, 3, let me see. That's going to be 3, 6, 9, 12, 15. It's only 16 instructions for this put S, okay? So even though you see a bunch of muck and you don't recognize these addresses, it's like, whoa, we were always over in 3000. What happened? Okay. I want you to notice a couple things, okay? One is, we haven't talked a lot about this yet, but when you make a subroutine call or call a trap routine, it takes the program counter and it saves it into R7, okay? I don't think we even talked about that yet, but it does. It saves it into R7. Look over here at R7, 3002. That's the incremented program counter. We executed instruction 3000, right? Which was that load effective address. And then, so then we got to the put S, and the incremented instruction counter goes 3000, 3001. The incremented PC is 3002. That's what's over there in R7, right there. And then when you call the RET instruction, then the RET instruction grabs whatever was in R7 and just shoves it into the program counter. Boom, fetch, decode, execute. Grab the next instruction from where? 3002. Boom, we're back where we were. That's the teleport. Okay, that's teleportation. Now, here's the thing. By sort of like convention, something else we really haven't talked a lot about is the fact that when you do subroutines, and this is a good illustration here in the trap routine, but when you do subroutines, you realize that any messing that you do with the registers has the potential to trash the registers, right? They come in a certain condition. You'd like them to go out in the same condition, okay? Meaning if I put a value in R7 and then for some reason I go touch it, I want to put it back, okay? I need to be able to save it away. Okay, so here's what that means. In practice, what happens is put S basically says, well, what are the things I deal with at all? I deal with R7 because that's what I use, to get back. So what I do is I store R7 away, and I happen to put it in location 467, 0467, which you'll notice, is just down here. It's just a dot fill, okay? 0467. And I don't even know, we can get into kind of why they're doing those dot fills, but bottom line is that's where it's going to put that 0467. So it just stores R7 away, and we might as well just step through that right now. Okay? So if we just executed that instruction. So 0467, notice what it's got, 3002. See it? That was the value in R7. Now you're like, okay, what is this crap over here? Instruction. Well, it turns out that basically, pretty much, about any bit pattern can be interpreted as an instruction, right? So you remember right? How do we know that that's an instruction? Social contract, right? It's just a social contract. We agreed. Well, right now, we know that that was the program counter, and then you shoved the program counter into R7, right, when you made the trap call, and now we're in this code and we're storing R7 into this memory location. The whole while, you and I are looking at this going, yeah, it's an address, right? We're like, yeah, I know that's an address. Everyone's cool with that, right? But the little simulator doesn't know that. The simulator doesn't have the social contract. So it always, in this spot right here, down here where it says instruction, it always just looks at whatever is there and tries to interpret it as an instruction. Turns out that 3002 actually is also that instruction, right? You know what I'm getting at, right? You take that 3, you take the first 4 bits, that's the opcode, you break it down, you decode it. If you decode it, that's the instruction. But it's a ruse. It can also be interpreted as ASCII values, but we know that it's an address. Okay? And I know I belabor that point from time to time, but it's an important idea that these things only have meaning because we give them meaning. And we just happen to know that's an address. Okay, R0, if you remember, was an address that we set up as the address of the first character in the string, right? Everybody cool with that? So there's R0. It was 3003, if you remember. So we're going to store that guy away. We're going to put it in 464. Let's go ahead and just scroll down so we can see what's in 464. Some fill. I don't know why that's the fill. I really don't. But let's go ahead and do the step. And so we executed that instruction. We put R0 there in 464. And notice there it is, 3003. So all we're doing there is just saving that away, right? That was 0467 was where we put R0. That's where we put R7. And then here's where we put R0. That's it. And all we're doing, you understand, is we're just keeping them safe. The ethic here is, what are the ones I care about? R7 I care about. R0 I care about. Okay? Now, R1 is one that we're going to use. Notice right there, we're going to use R1. And we're going to use R2. So I saved away R7 and R0 because we care about those coming in. So I'm going to store it. And now notice what I do at the very end. In reverse order. I load it back. So I save it away and I load it back before I leave. Does that make sense? I've got these things like put your valuables in your little bin, on your way out, you grab your valuables back from the bin. That's pretty good. Not bad. You know what I mean? You empty your pockets, your car keys, and then on your way out, you grab them, you put them back. It's just a way of saying, look, there are only 8 registers for the whole computer in this LC3 simulated computer. So if you're going to mess with stuff, you got to save it away. And then you got to put it back. So literally, I said, what did I say? 17 instructions? Something I can't remember. I think that's it. 4 of those instructions are storing 4 registers away, and 4 of those instructions are restoring those 4 registers back. So that's like 8. So that leaves, 1, 2, 3, 4, 5, 6, 7. It only leaves 7 instructions left, other than the ret. That's right. That's interesting. So it's also a way of kind of demystifying, like instead of seeing all this and going, oh, your eyes kind of fuzz. Instead of that, you look at it, you go, no. First 4 instructions are just saving those registers. The last 4 instructions here are just restoring those, pulling those back out of memory and putting those into the registers. Okay. And by the way, so I'm going to use R1, so I'm going to save it and restore it. And I'm going to use R2, so I'm going to save it away and restore it. Now, here is the bonus question. Are you ready for this? If you've got this, it'd be great if you could chat it. I'll give you, a few seconds. We're running short on time, but you're like, well, then it doesn't really matter, right? My logic doesn't matter. I do what I do, and when I make my function calls, I don't care, right? There's only one thing that gets trashed here that you cannot preserve. Any guesses what that is? There's one thing that gets trashed. And at least in the LC3, there's nothing you can do about it. I'm going to wait for just a minute. I guess I got to wait Oh, I got to wait longer than, well, I probably have to wait a whole minute for the YouTube folks. Discord people, come on. Show me your stuff. There's one thing that if I tweak it, if that thing changes and I need it, and it's before I made this call, it's going to get trashed inside here. Silence. Yes. Yes, Abby, silence. Excellent, Zach. Great response. Come on, folks. Come on. I'll give you a hint. Nope. PC gets saved away into R7, Walter, and shoved back. That's like more than a hint, isn't it? That's more than a hint. The control codes. See right there, see the CC where it says P? Okay. That's because the last thing I did, the last thing that I wrote to a register was positive. Well, what happens when I do this load right there? Any guesses? Well, it just depends. But it's going to get trashed. There's another load, you know, and there's an add which causes a result to be put into R0. Every time when I'm in this code, I'm going to toast the control codes. You got to pretty much count on that. So what you never want to do is an operation. Way to go, Zach. Yeah, Zach is like comforting, you know what, comforting. Zach's like, good job, Walter. And I'm like, Walter, you suck. You know? No, it was a good guess. Hey, and let's be clear about something. It was the only freaking guess. Everybody else was just spineless. And it was, you know, Walter at least had the courage to just try. So yeah, all right, good on you, Walter. Now, so here's the deal, but this is really important. What you don't want to do is like, you know, you do like a subtraction or you do something, right? And you're doing it in order to cause the control code to get set. So you know if something was greater than or less than or equal to or whatever, right? You know that. And so as a byproduct, if you do the operation, then make a call, and then do the branch with a condition, it's going to be screwed up. Because it's going to be basing the branch on the way the control codes were set when you came out of that operation. See? In fact, I want to do this. I want to do this really, really quick because maybe it'll work, maybe it won't. But I'm going to just reset, clear the output, okay? And what I'm going to do is I'm going to just step over. Now just see the control codes? It's Z. I go next, and it's now P. I do put S. I step past put S. Happened to be P. That's accidental, okay? That is just, you just have to know that's accidental. Okay, let me reset everything. And let's go again. So I'm going to go step. We're dropping into put S. And I'm going to go step. We're saving. Okay, now, what am I doing? I'm loading R1. I'm putting into R1, right, from a base register. What's that, right? The LDR is a base register. The base register is R0. I add 0 to it. So I go to R0, right? Sorry. I go to R0. That's the address of the string. I add 0 to it. I put that into R1. Okay, now R1 is my location. Okay? And now I'm going to branch on 0. Sorry. I'm actually LDR. Remember the part I like, don't be guessing? Hang on a second. Oh, this is not the right one. No. Yeah, LDR. Come on. Okay. Let me blow that up. Okay, let's go to LDR. First of all, there it is right there. base register, offset, destination register. But the question is, what's moving over there? And I did the classic mistake myself. Let's go to LDR. Come on. Okay, yeah, there we go. Yeah. Okay, so this is what's so important here. Notice what it says, that you sign extend this offset, right? You add that to the value of the base register. That gives you the address that you're going to be going for. The contents of memory at this address are loaded into the destination register. So it pulls it out of memory. Okay? So over here, where am I? That's not where I want to be. I want to go there. Yeah, okay. So in other words, it pulls the capital D and it puts it into R1. Let's look at R1. As soon as we do this thing, we go step. Whoops, step. All right. Notice the value, 4444. That's capital D in on the ASCII table. Okay. And now it does a branch on 0, because when it gets to the end, it's going to pull a value and the value will be 0. So this is the part that says when you get to the end, when the last character is 0, kick out. Ooh, we're out of time. That you kick out, and where do you go? 045B, which is right there. Restore, 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 and then kick out and return. Okay, I'm going to hit this really quick, and we'll kind of wrap this thing up. But that's the part where I check to see if I've hit a 0. Okay, now what do? I load R2 from 0460. What is 0460? I'm loading I. I'm doing LDI. I'm doing it again. I'm doing the dumb thing where I'm guessing. Let's go back to LDI. Okay. LDI stores the address of the data to be loaded into the destination register. So let me see. Oh, this is a PC offset. And then what is stored in memory at this address is the address of the data. So this is indirect. Okay? So this is indirect. And so I'm doing, well, I did the branch thing, which didn't go. So I'm here on this LDI. Okay, so down here in 460, I'm just trying to figure out, I'm going to look at that comment in a second, Brendan. But what I'm trying to figure out is what's in 460 FE04. Okay, and what's in FE04? We may have to come back to this. FE04 is another trap routine, I'm pretty sure. But we're going to load indirect from there anyway. And then we're going to branch on 0 or positive back to the top here to 0456. Man, we got to look back at it. I got to look back at it because all of a sudden it's like we're going to branch. Oh, I know what it is. We haven't gotten to this yet. It's about output. You got to check to make sure that that the console is okay to receive a character. That's what's going on there. Okay, so yeah, my bad that I didn't double check that. Then we do a store, and we do a similar thing. Anyway, let's come back to this. But you get the idea that we're down inside of this thing. We save the stuff away. You can see right there where we're checking to see if something is a 0. And then at some point, we're going to go branch NZP all the way back up to here, and we're going to grab the next character. Okay? So this is a part where we're going to increment R0, look at the next memory location, jump to the top, pull the value out. If it's 0, we're done. If it's not, we're going to do that print process. That's the short answer. We're a little over. I apologize. So that's pretty much, that's it for now. We'll come back. When we come back on Tuesday, let's jump straight into this stuff right. Hang on a second. We're going to jump back to this part here, the assembly process. We'll hit this first. We'll finish it, and that'll be out of that'll get us out of chapter 7. Okay. Okay. So anyway, ping me as you got issues, questions, concerns. You know, hit me, Talmadge, Devin in the testing lobby whenever you need us. And good luck. Good luck wrapping everything up and succeeding and all the rest. So, and then that's pretty much it. Okay, Brennan hears LDI and he thinks El Diablo. Fair. Fair. Okay, my friends. I am going to truncate our stream now.